going to look at where we're going to evaluate the pressure, the temperature, and the volume. And what's going to happen in all these scenarios is we're going to hold one variable constant. We're going to see with pressure, temperature, and volume, when we hold one of the variables constant, what's going to happen to the other two. So the first law that we have is Boyle's law, and this is Robert Boyle. He was a chemist in the late 1700s, I believe. I just pulled that from the back of my brain, so don't quote me on that, but I'm pretty sure it was the late 1700s. And he was the first of the gas law people that really looked at the relationship between, first, pressure and volume. So what he actually did was he was going to hold the temperature constant. And he did different experiments to figure out if you hold the temperature constant, what is going to happen to your pressure and your volume. So we made a PTV card in the last video. Whenever you hold one of the variables constant, in class we'll actually stab a hole in this. For the sake of these videos, I'm just going to use my fingers and cover up one of the variables. And when I go through and I cover up one of the variables, we can actually make like one of them go up and down. So like on this one, for Boyle's law, we're going to look at the relationship between our pressure and our volume. When we look at that relationship between our pressure and our volume, it's called an inverse relationship. That inverse relationship is going to occur, again, when you hold your, this is not wanting to move, when you hold your temperature constant. So if you have a temperature of 25 degrees Celsius, you're going to maintain 25 degrees Celsius. If you have a temperature of 300 Kelvin, you're going to maintain that temperature of 300 Kelvin throughout the entire experiment. And you're going to change your volume, or your pressure for that matter, and you're going to see what happens to the other variable. So what he actually found out, that this is an inverse relationship, meaning if the pressure goes up, your volume goes down. So when we increase our pressure, our volume of our gas, the amount of space that it takes up, is going to compress. It's going to go down. If my pressure goes down, that means that the volume of gas is going to go up. Or you can look at it in terms of volume. If I increase the volume of the container that it's in, my pressure is going to go down. If my volume of my container goes down, the pressure inside of the container is going to go up. There's more collisions. The more collisions that you have, the higher the pressure. The fewer collisions, the lower the pressure. So this is an inverse relationship. When one goes up, the other one goes down. So with your inverse relationship, you are going to look at the rate at which they go up and down, or down and up. So mathematically, when you see a graph, we're going to do a lab in this unit where we're going to graph the pressure versus the volume, and you're going to see what type of graph that is, but it's going to kind of like swoop up like that. So with your equation, you have variables. You have ones and you have twos. The one is what you start with. So you could also use I don't like to use letters with these because we get confused. So P1 is your initial pressure, your starting pressure. V1 is your initial volume. Then you're going to change one of those variables. Maybe your pressure goes up or down, however you want to do that, or you change your volume up or down, and we want to know what's going to happen when that occurs. So we have our new pressure and our new volume as the number 2. So your initial is the 1, the 2 is your new. So P1 times V1 is equal to P2 times V2. In the math problems, you're going to see 3 of those numbers. With those 3 numbers, you're going to solve for the 4th one using your Algebra 1 skills. So the math in this portion is not that difficult. Where people get tripped up with these is we have to always use the same units. Anytime you have a pressure for this whole entire unit, you have to use atmospheres, ATM. If they give you kPa, you have to put it into ATM. If they give you PSI, you have to put it into ATM. So no matter what, if you have a pressure, you're going to convert it to atmospheres if you don't already have atmospheres. We also have to remember that volume is always in liters. So we might have to convert between milliliters and liters using this conversion here that 1 liter is equal to 1,000 milliliters. Typically, I just move decimal places, but it's the same as dividing by 1,000. or you can set up a dimensional analysis problem. Whatever you're comfortable with there for that conversion. I don't actually grade on your conversions, so that's just up to you to actually get. Now, when you're doing those conversions, you have to use Sig Figs. If you have something in, I don't know, kilopascals and you have to put it into atmospheres, you're going to use Sig Figs to get that answer. Then you're going to take that answer and you're going to drop it into the math problem, and again, you're going to use Sig Figs to get your answer there. So each little step of this problem, you're going to have to use your significant figures to round each of your answers. So with these math problems, I actually have this on my document camera. I'm going to do two examples that you may see on your homework. This one says a diver blows a 0.75 milliliter bubble 10 meters under the water. So under the water, we've got a little bubble, and it's 10 meters down. That 10 meters doesn't really mean anything other than it's saying, hey, you're below the surface of the water. It says, as the bubble rises to the surface, the pressure goes from 2.25 atm to 1.03 atm. So the pressure down here is 2.25 atm. At this surface, it's 1.03 atm. What is the volume of air in the bubble at the surface? So I am solving for the new volume, which is V2. My initial volume is right here, what the bubble's starting at, which is 0.75 milliliters. With my pressure, I know that I'm starting at 2.25, so there's my first pressure, and that's changing to 1.03, so that's my new pressure. So once you kind of get an idea of what you need to do to solve the problem, you're going to use the equation P1 times V1 is equal to P2 times V2. So with this, we have to make sure that we have the correct units. I always have to use ATM. I always have to use liters. I have 0.75 milliliters. I need to convert that to liters. So how I do that is I divide by 1,000, or you can move your decimal place 1, 2, 3 times. So my V1 is 0.00075 liters. I'm just going to rewrite it down here just so I have it handy for me. I don't need the 10 meters because that just tells me extra information. I have P1, I have P2, and I'm solving for V2. So all I have to do is plug it into my equation. So P1, 2.25, times, I get into bad habits on that, times V1, 0.00075, is equal to P2 times V2, which I don't know. So to get my answer here, I passed my 7th grade algebra skills. So to get V2 all by itself, I have to divide to bring it over. So I'm going to divide this side by 1.03, and I'm going to divide this side by 1.03. I'm going to get my calculator, and when I get my calculator here, I take 2.25 times 0.00075 divided by 1.03. Looking at Sig Figs, this number has 3 Sig Figs, 2 Sig Figs, 3 Sig Figs, so that means that this answer can only have 2 Sig Figs. So V2, my new volume, is 0.0016. I'm solving for volume. Volume is always in liters. Now looking at this, just to see if that answer makes sense, I have my PTV card. It says that my pressure is going down. My pressure is decreasing. So with my pressure decreasing, temperature is being held constant. When my pressure goes down, my volume of the air goes up. I started at 0.00075. It went up to 0.0016. That answer makes sense, so that's likely the correct answer. Looking at this one, it says the volume of a gas is 99 kPa at 300 milliliters. If the pressure increased to 188 kPa, what is the new volume? So right away, I know that I'm solving for V2. It also tells me that my pressure is starting at 99 kPa. It's increasing to 188 kPa. That initial pressure has a volume of 300 milliliters. So once I have my variables kind of all lined out like this, then I need to check the units. I always have to use atmospheres. I always have to use liters. So 99 kPa, that's pressure, that's going to have to turn into atmospheres. So to do that conversion, I have 99 kPa. That conversion factor, it says that there's 101.3 kPa in 1 ATM. So again, I'm going to grab my calculator. This number has 3 Sig Figs, so I'm going to have 3 Sig Figs here. I'm going to have to do the same thing with my 188 kPa. So I'm going to divide those two, 188 divided by 101.3. This number is 3 Sig Figs, so I'm going to have 3 Sig Figs here, 1.86 ATM. So I converted that one, I converted that one. Milliliters has to turn into liters. So we move our decimal place or divide by 1,000. Move my decimal place 1, 2, 3 times. Before that conversion, this number had 4 Sig Figs. After the conversion, it needs to have 4 Sig Figs. I'm going to write this down here just so it's a little more clear. So I have 0.3000 liters. Once everything has the correct unit, then I plug it into the equation. My equation is P1 times V1 is equal to P2 times V2. So P1, my initial pressure, is this 99 kPa, which I changed to 0.977 ATM. My V1 is my initial, oh, I wrote that down wrong. Sorry. I realized that I wrote down a number 2. That should be a number 1. Is 0.3000, 1, 2, 3, yep, okay, is equal to P2, that's my new pressure, so 188 kPa became 1.86 ATM, times V2, which is what I'm solving for. So now in order to solve for V2, I'm going to divide both sides by 1.86. So I have 0.977 times 0.3 divided by 1.86. 3 Sig Figs, 4 Sig Figs, 3 Sig Figs. My answer has to have 3 Sig Figs. 0.158. I am solving for V2, volume. Volume is always in liters. To see if this number makes sense, my pressure is increasing. So 99 to 188. When my pressure increases, my volume should decrease. My volume started at 0.3, now I'm at 0.158, so that makes sense. I hope that helps. This equation will be given to you, but P1 times V1 is equal to P2 times V2. And the big thing to remember is you have to use the correct units. The correct units that we have to use are ATM, and we have to use liters. If you don't have those units, you have to convert it out, so you do. If you guys have questions, be sure that you ask. Otherwise, have a great day.